So it is a similar thing that you already learned in your first year statistic. Okay. So during your first year, maybe kita lebih kepada application. Okay. Lebih kepada application where you have your, you already mentioned about one tail test, two tail test, and then kita ada several testing hypothesis. Either you want to use Z-test, T-test, and then also chi-square test, dan juga last kali kita ada apa? Ratio of two variance where we use F-test. Okay, so konsepnya sama. Okay, konsepnya sama. So actually here, nampak saya punya slide ni? Sekejap, macam mana ni? Tak naik pula dah. Okay, boleh clear? Okay. So dia punya objective of statistical testing is to test a hypothesis concerning the values of one or more population parameter. So at your stage of your final year ataupun third year, so you need to differentiate what is your, the term that we use is parameter and also statistic. So when we mention about parameter, so that means it describes the characteristic of your population. Tapi kalau kita guna term statistik, that one is based on your sample, your observation. So kalau statistik, it is just like X bar, kita punya S, kita punya S square, that is your value lah, sample mean, sample variance. Kalau parameter, that means we are concerned about your parameter mu, parameter again sigma, sigma square, and also pi. Okay? So actually hypothesis testing is a method of making statistical inference, okay, by establishing a hypothesis that we call as null hypothesis. So based on null hypothesis and we using some data, so that means we collect some data, your observation, and then we decide whether to reject or fail to reject the hypothesis. Okay, so kalau hypothesis dia punya statement dia. So we have null hypothesis and also alternative hypothesis. Okay, null standard lah H0, alternative normally we use H1. Okay, but certain reference was written in terms of HA, sama je. Okay, so again, you have one tail test, two tail test. So one tail test again, kita dah ada your null, theta equals to theta naught. So alternative, it can be either less than or greater than. So kalau less than, greater than, so this one is one tail. So kalau two tail, your alternative is unequal. Okay, itu dia punya main difference that you already learn in your first year statistic. Okay, because second year mathematical statistic kita tak repeat pun on your testing hypothesis. Okay, so that is your knowledge lah So again, statistical hypothesis is an assertion about the distribution of one or more population parameters. Okay, so cuba kita ada dua term lah kita panggil sebagai simple statistical hypothesis. Satu lagi kita panggil sebagai composite. Okay, so if the statistical hypothesis is completely satisfy the distribution, it is called a simple statistical hypothesis. For example, let's say kita dah state, okay, katakan null kita theta equals to 1. Okay, your alternative theta equals to 2. So that is one is we call as a simple statistical hypothesis. Kalau kita ada composite statistical hypothesis, so in case lah kamu punya alternative can be less than ataupun greater than ataupun kita punya null ni kita ada in terms of theta greater or equals to 1 macam tu. Okay, and then your alternative you need to write lah theta less than 1. So that one we call as a composite statistical hypothesis. It does not completely satisfy the distribution. Okay, so because let's say kita ada theta greater than or equals to 1. So it can be 1, it can be 2 or 3 and so on. Okay, it does not completely satisfy the distribution. So that one we call as a composite statistical hypothesis. Okay, so itu just definition. Okay, element of statistical test. Okay, you have your H0, the null hypothesis, the hypothesis that you want to be tested. Alternative, is the hypothesis to be accepted in the case when your H0 is rejected. Dia punya alternative dia. Okay. So we have test statistic. Okay, we conduct a test statistic. Normally, let's say Z test, T test, F test. So that one is your test statistic. It is a rule when the experimental values, so based on your sampling, okay, have been obtained leads to a decision, either you want to accept or to reject the hypothesis under consideration. Okay, depends lah pada kamu punya alternatif tu macam mana. Okay, and then you have also critical region ataupun rejection region. Kawasan mana kita nak reject kita punya null hypothesis. So the region associated with test statistic is the other function part of statistical test. It is the set of values for the test statistic result in the null hypothesis being rejected. Okay, satu lagi kita ada critical value lah. For example, let's say if you conduct a Z test, you have Z 0.05, for example, from your stats table. So this is the value. So kalau yang ni kita panggil sebagai critical value. Okay, say off tu. So this one we have a critical value. So this is your Z alpha, alpha 0.05. So we have here is 1.6449. So that one is your critical value. Okay. So then we decide you want to reject or fail to reject the null hypothesis. Okay. And then you have type 1, type 2. Okay. In our first year statistic, we also mention about type of errors. Either type 1 error ataupun type 2 error. Kita define je. But normally, what we use is type 1 error in your first year statistic. Okay. But during your final year here, okay, for this syllabus, both definition, you need to know. Okay, what is the definition of type 1? So, kalau type 1 error, rejecting H0 when your H0 is true. Kita reject null hypothesis. Tapi padahal your H0 tu statement kita dalam null hypothesis padahal dianya adalah betul. Tapi kiranya kita buat kesilapan. Kita menolak sesuatu hypothesis. So kalau boleh bila kita buat conduct type 1 error, kita nak error kita sekecil yang mungkin. So that's why normally sometimes we test at our alpha 0.05. Sometimes kita nak precise lagi, kita test lah dekat 0.01. Okay? Sebab kita punya statistik it can be manipulate jugalah. It can be modified. So let's say lah kita conduct. Let's say lah if your PSM for example. Okay? Maybe some of you doing your statistic punya approach. Okay, you have your statement. Okay, based on your punya simulation ke apa ke you conduct. You nak check you punya p-value. So normally if your p-value is less than alpha, you will reject your H0. Okay, katakan kamu pemikiran sepatutnya dia reject dalam dia punya null hypothesis. But then your punya outcome fail to reject. So you can modify either you want to use alpha 0.05 ataupun alpha 0.01 provided you give a justification. Okay, kena add alpha 0.05 apa yang terjadi, alpha 0.01 apa. Okay, kena adalah dia punya justification dia. Then your model or your analysis can be accepted. Okay, sebab kita proof ataupun kita reasoning tu based on statistical reason. Okay, and then so that one is your type 1 error. So kalau type 2 error, you accept your H0. You accept your H0 when your H0 is false. Okay, kita accept kita punya null hypothesis. Padahal H0 kita tu salah. Okay, maksudnya dia punya H1 tu betul lah. H0 tu salah. Tapi kita accept. So that one, type 2 error. Okay, probability of type 2 error ni kita consider sebagai beta. Okay, so both definition, please remember. Apa dia punya definition dia. So kalau type 1 error, reject H0 when H0 is true. Type 2 error, you accept your H0. But your H0 is false. Okay. So next, so if we choose a very small value of alpha, ini alpha tak nampak macam alpha pula. Okay, we will making it very difficult to reject the null hypothesis. Okay, so katakan alpha 0.01 dengan alpha 0.05 So katakan saya ambil, okay, Z 0.05, kita ada 1.6449 from the stats table. So kalau Z 0.01, you will have 2.3263. Itu dia punya value dia. Okay. So katakan kita punya Z test lah, kita conduct Z test. Okay, kita nak compare. Okay, katakanlah kita ada Z test kita 2.1. Okay, 2.1. So kalau Z test kita normally lah kalau if your Z test is greater than Z alpha, you will reject your H0. Okay, Z test is greater than Z alpha, reject H naught. So based on your alpha 0.05, kita akan reject H naught. Tapi based on your alpha 0.01, we need to fail to reject the null hypothesis. So that's why if we choose a very small value of alpha, maksudnya alpha 0.05, kecil lagi, alpha 0.01, we will be making it very difficult to reject the null hypothesis. Okay, sebab kamu punya Z test ni 2.1. So kalau let's say compare dengan alpha 0.05, dah reject dah. Tapi compare dengan alpha 0.01, agak sukar untuk kamu menolak that hypothesis sebab the value dia adalah 2.3. So dia punya outcome ataupun dia punya result akan fail to reject H naught. Okay, fail to reject H naught maksudnya accept H naught lah. Okay, so type 2 errors will be common. Okay, but if we choose a larger value of alpha, type 2 error will be less common. Okay, terbaliklah dia punya apa dia? Dia punya complement dia lah ya. Okay, so itu dia punya konsep lah bila let's say normally lah during your first year kita kata okay, test at alpha 0.05. Okay, increase your alpha atau reduce your alpha. Okay, apa yang terjadi? So what is your reason? Is it you have the same conclusion? Itu kamu kena justify lah. Okay, so ini dia punya point lah yang you need to understand. Okay, bukannya memorize tapi understand dia punya konsep. Macam mana nak understand? Ambillah beberapa contoh. Letaklah alpha apa-apa, compare. And then try to make a reasoning. Okay, dia punya explanation dia. Okay, so that is your type 1 error and also type 2 error. So type 1, reject H naught when H naught is true. Type 2, accept H naught when your H naught is false. Okay. So next we have the term the power function of a test. Okay. Kita tengok dulu sekejap. Okay. So in your first year tak ada the power function of a test. Okay. So this one in the syllabus lah ya. The power function of a test is normally we define it is as the ability of the decision rule to recognize correctly that your H naught is false. So the power function is normally is the probability of rejecting the null hypothesis given the null hypothesis is false. Apa dia punya power function dia? Okay, so that is the power function of the test, the probability. Okay, probability of rejecting the null hypothesis given that your H naught is false lah. Yeah. So again, the power function of a statistical hypothesis H naught against H1 is that function defined for all distribution under consideration. So kita kena tengok dia punya null, kita kena tengok dia punya alternative dia. Okay, so it is a function that yields the probability of rejecting H naught. Okay, probability of rejecting H naught under consideration, which yields the probability that the sample point falls in the critical region C of the test. Okay, so the idea the power function ni apa probability of rejecting H naught? So depends lah H naught dia berapa. Okay, ataupun depends on the parameter, sorry ya. The value of the power function at a parameter point is called the power of the test at that point. Okay, it depend pada parameter dia. Parameter katakan probability kita reject H naught when theta equals to 1. And then probability reject H naught when theta equals to 2. So it depends. So that is your power function. So depends on the parameter. So kita boleh compare lah. Kalau theta equals to 1, apa dia punya power function dia? Kalau theta equals to 2, apa dia punya power function dia? Okay. So power function ni dia punya ni adalah lebih kepada apa dia punya probability of rejecting the null hypothesis. Okay, kita assume lah the true population mean is equal to the critical parameter value. Ataupun kita boleh tulis sebagai probability of rejecting the null hypothesis when the parameter is equals to some value of theta. So kita akan dapatkan dia punya power function of a test in terms of calculation lah. Okay, so itu probability of rejecting the null hypothesis under the parameter. Okay, so that's mean the value of the power function at a parameter point is called as the power of the test at that point ataupun at that parameter lah, sama ada at theta equals to 1 ataupun at theta equals to 2 for example. Okay, so again here, okay, so kalau power function, okay, power function ni kita denotekan sebagai simbol K theta. Okay, biasanya lah kita tulis sebagai K theta. Okay, power function dia. Okay, kita tengok dulu kat sini dia punya apa definition lah sikit ya. So, probability of rejecting H0. Okay, normally kalau beta tadi, probability of accept H0 when H0 is false. So, kalau saya tulis beta, dia adalah probability accepting H0 given that your H0 is false. Okay. So, kalau power function, probability of rejecting the null hypothesis, okay, the probability of rejecting the null hypothesis given that H0 is false is the same thing as 1 minus beta. So, kalau kita dah ada value beta, kalau kita nak dapatkan probability of rejecting H0 when H0 is false, so 1 minus beta. So, it is called as the power of the test when H0 is false ataupun samalah kita tulis when your H1 is true. So, kalau H0 ni false, maksudnya H1 ni betul lah kan? H1 is true. So, itu maksudnya power of the test tu. So, it can be either power of the test, okay, when your H1 is true ataupun when your H0 is false. Okay, probability of rejecting H0 when your H0 is false. Okay, that one first. Okay, sekejap ya. Okay, here. So, maksudnya juga, the power function of a test is a probability of not making type 2 error. Okay? So, sebab kita ada 1 minus beta. So, kalau 1 minus beta, okay, 1 minus beta, okay, so that means it is the probability of not making type 2 error. Okay, beta probability accept H0 when your H0 is false ataupun fail to reject H0 when your H0 is false. Power function dia mesti probability of rejecting H0. Okay, but it depends. So, given that H0 is false, so 1 minus beta. Satu lagi, kita ada alpha kita tadi. Dia reject H0 juga, tapi H0 is true. Okay, so when the question asks you, find the power function of a test. Tapi dia tak cakap, okay, either H0 is false ataupun H0 is true. So, you have two value. So, kalau probability of rejecting H0 when H0 is false, so you have 1 minus beta. And then the other one, probability rejecting H0 when your H0 is true, it is your alpha. Okay, so alpha ni in terms of apa dia? Definition dia ya. So alpha ni sama juga probability rejecting H0 when H0 is true. It is also the significant level, size of the critical region, for example Z alpha, T alpha, power of the test when H0 is true, and also probability of committing a type 1 error. So maksud semua ni sama, which is your alpha. So there are several definitions. Alpha is your significant level. Alpha is size of the critical region. Alpha is the power of the test when H0 is true. And alpha is also the probability of committing type 1 error. So katakan saya cakap macam ni, test at using the probability of type 1 error, solve this one. So dalam automatic, dalam you punya apa tu, pemikiran kamu, your alpha is sekian-sekian lah yang diberi pada soalan. Sebab dia memberi maksud yang sama ataupun test at 5% significant level. So that is also your alpha. Okay, dia memberi maksud yang sama ya. So alpha tu. Okay, so dia mana ya? So kita ada dua ya. Kalau power function, it depends pada ni. Sama ada theta dia berapa. So katakan macam inilah ya. H0 kamu, theta equals to 1. H1 kamu, theta equals to 2. So you want to find power function of the test. So probability, kita reject H0. Okay. When H0, katakanlah dia punya value theta equals to 1. Probability reject H0. Okay. When theta equals to 2. So you have two values. Sorry. Betul lah. Okay. Okay. So again, kita ada dua value sama ada kita menggunakan kita punya value from theta equals to 1 ataupun theta equals to 2. So kalau H0 is false, maksudnya kau punya H1 dia is true. So you substitute that one. Ataupun kita dapatkan dia punya alpha. Probability rejecting H0 when your H0 is true. So what is the value dia? Okay, so kalau H0 is true, we take lah theta equals to 1. Okay. Okay, nanti saya tunjuk dia punya example lah macam mana kita ni kan. Okay. So again here, okay, so kalau ini kita ada benda yang sama juga. Okay, ini power of the test. So power of the test including the choice of alpha, the sample size and also the true value of the parameter. Okay, that depends pada several factor. So one more thing that you need to know, as your sample size increase, it will increase the power of the test. Okay, so semakin besar, katakan kita compare lah, n equals to 10 dengan maybe n equals to 30. So maybe the power of the test will be more precise when your sample size is increasing. Okay. And then one more thing, if the significant level is increased, maksudnya kau punya alpha ni increase, the power of the test also will increase. Okay. If the significant level increase, power of the test pun increase juga. Yeah. So that one. Okay. Okay, dia punya statement je lah ya, dia punya definition dia. I think tu yang tu kamu boleh baca jugalah dalam kita punya notes here. Okay. So this is how you want to construct your statistical test actually. Okay, 3.5 ya. So 3.5 in your notes Notes saya dah upload ya. Okay, kita ada rejection region, kita denote sebagai C. Okay. So kalau dia punya acceptance region, kita pakailah C prime. Katakan ya. C adalah rejection region. Complement dia C prime adalah acceptance region. So if the experimental values of x1, x2, xn, okay, are the points, so x1, x2, xn belong to C, belong your rejection region, so we shall reject null hypothesis. So otherwise, kalau dia belong kepada kita punya acceptance region, so we should accept our null hypothesis ataupun we can say that we fail to reject kita punya null hypothesis. Okay, so the particular point in C tu adalah kita punya critical value dia. Okay, yang nak decide reject ataupun fail to reject. So cuma standard formnya kita pakai C for kita punya rejection region. So kalau C prime, it should be the acceptance region. So if your data set support ataupun fall in your critical region ataupun rejection region, so kita reject lah kita punya null hypothesis. Okay. Sekejap Okay, kita refer pada example 3.1. So again, here you have your X is normal with mean theta, where is 100. Okay, normal distribution So kamu punya mean theta, sigma square kamu adalah 100. Okay, suppose that past experience with this random experiment indicates that theta is equals to 75. But that now theta is greater than 75. Kita ambil sampel size 25. Okay, size 25. Your n is equals to 25. Okay, so suppose that the sample space A is the set of this one, and then kita adalah I equals to 1 up to 25. So let the critical region subset C be this one. Kita ada S1, X2, Sn, X25 greater than 25, 75. Okay, so ini kamu punya N. Ini actually kita punya theta. Okay, so kita nak dapatkan dia punya power function of the test. Okay, you want to set up your power function of the test. So in here, kita ada probability. So maksudnya here you will have your, katakan saya tulis balik kita ada summation xi greater than 25 and then 75 macam tu. Okay. So n is equals to 25. So kalau saya buat summation xi over 25, it give you just 75. So ini adalah kamu punya x bar. Okay? Okay, kamu punya n lah. N is equals to 25. So summation xi over 25, that is your x bar. So you want to define your power of the test. Okay, kita nak define power of the test kita. So power of the test biasanya kita denote dalam case ni, kita denote sebagai K theta. Okay, K theta. So this one K theta. So what is your power function of the test? Is probability of rejecting the null hypothesis. Okay, probability of rejecting the null hypothesis. So kalau base balik pada ini, okay, kita reject H0 ini. Nampak Reject H0 bila X1, X2, Sn belong kepada kita punya critical region. Okay, ini. Set C kita. Ini. Bila summation Si greater than 25, 75. So kalau saya simplify kan, saya dah X bar greater than 75. So your power of the test is actually is given as this one lah. Probability X bar greater than 75. Okay, ingat balik dalam kamu punya nak selesaikan probability, dalam testing hypothesis, normally we use X bar. We didn't use X. Kalau X tu kita nak selesaikan taburan normal macam biasa. Tapi kalau testing hypothesis kan kamu ada dia punya standard normal, X bar minus mu sigma over square root of n. Macam tu. So everything is term of your sample mean. So that's why I modify, I divide by n, and then you get lah X bar greater than 75. So K theta adalah probability of rejecting the null hypothesis. Kita nak reject H dot, macam mana? Keadaannya macam mana? Okay, bila summation Si ni greater than 25, 75. So you know that 25 is your sample size. So you divide. So that's mean, case-nya bila X bar greater than 75, katakan kita punya value nanti, kita punya value of X bar lah. Kita katakan kita buat sampling, kita ambil observation ni. Kita compute X bar kita 79 for example. Then you reject lah kita punya null hypothesis. So itu maksudnya. Okay. So itu adalah power function of the test. Kita define dulu. Okay, kita define K theta kita adalah probability of X bar greater than 75. Okay. And then again here, because this one is a normal distribution. Okay, ini taburan normal. So macam mana kita nak dapatkan probability? So again, X bar minus mu theta. Okay, divide by sigma square ataupun sigma over square root of n. Okay, sigma ataupun square root semua 100 divide by your n, which is 25, 75 minus theta square root 100 divide by 25. So kalau kita simplify kan, kita ada macam ni kan, Z. Betul tak? Okay. So yang tinggal 75 minus theta. Again here, okay, 100 divided by 25, which is 4, square root of 4. Saya just tulis 2 So that again, you can get probability X bar greater than 75. So define dia punya power function, letak dalam bentuk macam ni. So this is your power function of the test. Okay, power function of the test. Okay, soalan yang pertama ni. So menjawab. Okay, find the power function of the test. Kita tak selesaikan apa-apa lagi. Kita just tulis dalam bentuk general formula. Okay, yang kita nak dapat value ni, nanti B ni. Okay, B. Okay, boleh faham ke? Okay. Mana saya boleh sila tengok jam sekarang kau apa ya? Nanti mana saya punya jam tak keluar pula kat sini. Okay, jap. Okay, kita continue on. Okay, this one find the power function. So next kita nak dapatkan theta 73, 75, 77, 79. Apa dia punya value dia? Okay, saya tulis balik. So K theta is given as probability Z greater than 75 minus theta divided by 2. Okay, that one. Okay, now you want to find what is the value at theta equals to 73. Okay, part B So katakan theta equals to 73. Okay, K 73. Okay, K73. Probability, again Z, 75 minus 73 divided by 2. So, ini yang kita nak guna stats table ni. Okay. Okay. Tapi saya kena mention juga So, sebab, okay, since kita punya final examination nanti, tengok final examination nanti is physical, face to face. So, depends juga pada, I'm not sure, mungkin yang third year dia guna, third year student dia guna yang baru punya, which is dalam stats table tu kita ada list of formula. Tapi untuk yang final year yang sekarang ni, saya tak sure sama ada kamu guna which stats table. So, kalau yang pink-pink tu adalah Prof. Hishamli punya. Okay. So, perbezaannya, taburan-taburan lain tu saya rasa sama. Okay. The difference is, in terms of normal distribution, the way, nanti kamu tengok check balik stats table kamu apa. Kalau yang pink tu, okay, yang Prof. Hisham punya tu, okay, dia punya shaded area dia, okay, check dalam kamu punya ni, dah final year, kena faham lah konsep bila baca table. Okay, the shaded area is between 0 and this one. Ini. Okay, itu yang Prof. Hisham punya. Tapi kalau yang apa? Yang kita orang punya, okay, sorry lah, saya punya normal shape ni dah tak jadi shape dah ni. Kalau tak salah saya sini kan? Betul tak? Sini ke sini? Antara dulu lah. Okay. Either this one. Tak. Yang mana satu lupa dah pula. Dia lain sikit lah. Kamu punya tu sama ada Z greater than ataupun yang macam ni. Okay. I'm not sure. Okay. So tengok kamu punya shaded area dia. Okay. Konsep nak baca value akhir sama. Cuma cara nak baca daripada taburan normal tu berbeza sikit. Okay. Dan yang kita supply untuk final exam nanti adalah yang version baru. Okay. Version baru. Okay, which is yang maybe budak student third year punya yang ada nama saya and the gang lah. Ada 10 orang punya nama tu kat situ. Okay. So, itu yang kita pakai. Okay. Tapi nanti saya screenshot lah saya punya yang terbaru punya table normal dan cuba kamu faham lah macam mana kita nak baca dia punya jadual tersebut. Okay. Nanti later on lah. Hari ni tak sempat pula, lupa. Okay, so that one. So again depends pada kamu punya ni, kita nak cari value dia adalah this one. Okay, kita nak cari theta equals to 73. So 75 minus 73 divided by 2. So you need to find probability Z greater than 1. So kalau Z greater than 1, so it will give you the power function dia 0.1587. Okay. And then kita proceed lagi. Kita nak dapatkan theta pula 75. So K 75. So probability Z greater than 75 minus 75 divided by 2. So probability ini Z greater than 0. Okay. Ini 0.5. Okay, saya bagi dulu dia punya value, nanti you all check macam mana you all nak dapat daripada stats table. Okay, so ini K77. Okay, probability Z greater than 75 minus 77 divided by 2. Caranya sama juga macam first year kamu belajar. Nak baca table and so on. Benda yang sama, review balik lah So Z greater than minus 1. So it should give you 0.8413. Okay, and then the last one. Kita ada K79. So probability Z greater than 75 minus 79 divided by 2. So Z greater than minus 2, which is 0.9772. So this value. Okay. So you have 4 values. Okay. Itu kita punya theta dia. Okay. So dia kata yang last plot the graph of K theta. Okay. So kalau saya plot dia punya graph, macam tu je lah lebih kurang lah So this is your K theta, dia punya value. Okay. So kata ikan ini kamu punya theta 73 and then 75, 77, 79. Okay. So kalau 73 tadi kita ada 0.15, so dia naik lah So lebih kurang sini, and then sini, and then the last one kita ada lebih kurang lah So dia naik lah, lebih kurang lah macam tu lah. So dia naik ke atas. So that is your power function of the test K theta. Okay. So berbalik-balik kepada kita punya ini, kalau kita tengok K theta kita So maksud tadi K theta adalah probability of rejecting the null hypothesis. So katakan kita masuk kita punya null tadi. Mana null kita? Okay. Okay, ni sebenarnya sekejap ya. Nah, sini saya tulis balik dalam soalan dia. Theta less than or equals to 75. Alternatif dia theta greater than 75. Okay. Inilah. Okay, theta less than or equals to 75. Alternatif is theta greater than 75. So, kalau theta tu sama dengan 75 ataupun theta tu 73, so it should belong to your null hypothesis. Okay. Tapi kalau theta tu 77, 79, it should belong to your alternative. Okay. Bear in your mind. So, kalau theta 73, 75, dalam null lah. Less than or equal. Tapi kalau 75, 77, 79, it should be in your alternative. Okay, now kita baca balik kita punya K theta. Sebab ini power function ni. Okay, so kalau theta tu 73, maksudnya dalam your null hypothesis, probability of rejecting your null hypothesis when your H0 is true is 0.1587. Okay. Yeah. Okay, probability of rejecting null hypothesis when your H0 is true 0.1587. Kenapa saya cakap H0 is true? Sebab theta dia 73 less than or equals to 75. So your H0 is true lah maksudnya. Okay, theta kat sini. So yang kedua 75. So 75 kalau betul-betul fix theta equals to 75, you get 0.5. Okay. So if your theta is true, for example lah kita ambil theta equals to 75. Probability of rejecting the null hypothesis. Kita nak reject null hypothesis tu. Bila theta kita true, separuh, sebahagian 0.5. Right? Betul tak? Kita nak reject null hypothesis tapi kita tahu kita punya null, kita punya theta tu betul 75. 0.5 which is high probability. Okay, kita tengok satu lagi. K77. Okay. So this one probability of rejecting null hypothesis when your theta is equals to 77, maksudnya your H1 is true lah. H0 is false. So probability dia adalah 0.8413. So ini pun sama. Probability of rejecting H0 when your H1 is true is 0.9772. Okay. Tetapi the idea is here, kalau kita tengok K75. Okay. So since it has high probability of rejecting the null hypothesis, when H0 is true, is nearly 50%. So this kind of test does not appear to be a satisfactory test. Okay. So chances kita nak tolak kita punya null hypothesis, padahal hipotesis kita tu benar tu hampir 50%. So it cannot appear to be a satisfactory test lah. It's not efficient lah. Kita punya test one ni. Kita punya kita punya case yang pertama lah. Okay, for this example. Okay, sebab itu kita cari dia punya power function of the test. Nanti kita akan compare balik dengan this one pula. Example 3.2 and also example 3.3. Nanti kita akan buat secara conclusion apa dia punya value dia. Okay. Okay, jap. Kan kau apa? Jam? Mana saya punya jam pula? Tak nampak jam.
8.50.
50, you order kelas kan? Okay. So ini nanti saya sambung balik. So just bear in mind. So ini kita punya konsep awal. Kita ada 3 case sebenarnya. Example 3.1 ni refer pada first case. Example 3.2, your second case. Okay, tapi theta dia sekarang 78. Kita nak compare balik. Kita nak kira benda yang sama. So last, dia suruh cari pula, dia bagi macam ni. Tapi kita nak cari N, kita nak cari C. Macam mana kita nak check? Which one is more efficient? Okay. So dia agak berbeza sikit dengan you all punya Yalah, again ya, first year tu application. Ini teori di sebalik itu. Maksudnya understanding lah, you punya understanding. Kalau case dia macam ni, macam mana? Apa dia punya power function, apa N yang paling sesuai, and so on. Okay, so kita nak menunjukkan if you increase your sample size, actually, dia punya result lah, general conclusion. Kalau increase your sample size, dia lebih um, precise lah kamu punya power of the test ataupun analisis. Tetapi, dia punya risikonya, kalau kamu buat sampling, banyaklah pula sample size kamu nak pakai. Itu je. Macam kamu you all mungkin, siapa itu tanya saya? Azizah nak buat survey sampling. Okay. How many data that you need to collect? Kan? How many sampling yang paling sesuai? So jawapan saya, it is 30% of your the whole population. If you want to conduct study in UTM punya apa-apalah, everything must be 30% daripada the whole population. Baru kita boleh accept it in statistical punya way lah. So everything kalau kita buat macam for those engineering ke apa-apalah yang relate, kalau dia orang menggunakan kaedah statistik, dia orang nak collect data ke apa ke, mesti comply that one. Baru kita boleh percayalah dia punya model. Itu dia punya implication lah why you need to learn statistic. Maybe after this you can explain to your friend in other faculty ataupun other field how statistic is important when you want to do the sampling ataupun apa-apalah analysis model and so on. Okay, kamu kena bagi reasoning lah. So itu yang kamu boleh masuk, macam setengah-setengah student mungkin dia nak masuk industrial, nak masuk kawasan industri. So that's, you need to show lah macam mana you punya maths punya apa yang kamu belajar tu boleh serap ke arah industri. Apa yang kamu boleh apply dari situ. Okay? Okay, so the rest tu insyaAllah saya akan sambung next week lah kan, hari Khamis lah. Hari Isnin tak ada. Kalau in case lah, boleh sempat habis sempat. Okay, tapi on time lah. But again, you need to, apa tu,